Hello students, good morning. Successfully we have completed lesson 1 metallurgy, and today in this video we are going to start the lesson 2, that is P block elements 1. Students, we have P block elements 2. So the study of P block elements is somewhat heavy, so that the curriculum is splitted into 2 lessons, P block elements 1 and P block elements 2. So P block elements 2 will be the next lesson, and now we are going to see P block elements 1. Okay, ma? Okay, ma. Dear students, about the various blocks of elements, how many blocks we have? We have S block, P block, D and F blocks. About them already we have studied in 11th standard, isn't it? Yes. Okay, now we are going to study in a detailed manner about the P block elements, their compounds, their practical applications and so on. Okay, okay, let us move on to the topic. Dear students, before starting the lesson, I would like to show you the P block elements, the position of P block elements in the periodic table. That is why these set of elements I have shown in this slide. Dear students, look at these blocks of elements. These are called as P block elements. The first element is boron, and the elements below boron are called as boron family. Then the elements below carbon are called as carbon family, then nitrogen family, oxygen family, halogens, and finally noble gases. So in the periodic table, group number 13 to 18, already we know periodic table contains 18 groups, no? So out of those 18 groups, the group number starting from 13 and ends at 18. So these elements collectively called as P block elements. Okay, ma? Okay, ma. Okay students, this is the introductory part about P block elements. Let us start from the beginning. How many elements, how many blocks we have in the periodic table? Yes, very good. We have 4 blocks in the periodic table. What are they? Can we recognize? Yes, they are S block elements, P block elements, D and finally F block elements. So these are the blocks of elements present in the periodic table. Okay, then why these set of elements are particularly called as P block elements? Surely we should have a doubt. Okay, why certain elements are called as S block, why certain other elements are called as P block, and so on. Why certain other elements are called as D block, and why certain other elements are called as F block elements. Since we are studying about the P block, I have given the answer for why these elements are called as P block elements. The answer is very clear. The elements in which the last electron enters. Last electron means it is called as valence, the electron present in the valence shell. Okay, so the elements in which the last electron enters in p orbital. Okay, so those elements will be called as P block elements. It's given here. What are P block elements? The elements in which the last electron enters in p orbital are called as P block elements. Then in the periodic table, what is their position? As I told you already, group number 13 to 18, which means group number 13, 14, 15, 16, 17 and finally 18. So those groups are collectively called as P block elements, which means in all these group of elements, the last electron will present in the p orbital. Okay, okay. Then we are going to have a look on the important elements from the P block. Dear students, we know that a gas which is very important, or it is must for living. What it is? It is oxygen gas, and oxygen is present in the P block. So that is given in the first point. Oxygen, it is used for the survival of living things. Then second one, aluminium. Aluminium in our household also we are using in so many ways. Also it is used in to make the parts of the aircraft. So aluminium is also an element of P block. Then thirdly, it's given about silicon, germanium. So these elements, silicon and germanium, are called as semiconductors. About semiconductors, you may have an idea. Okay, so these are the important elements given from the P block elements. What are they? Oxygen, aluminium, silicon, germanium. Many elements we have, but these are the elements given in your textbook as important elements. Okay, okay. Okay, students, this is the first thing we are going to see in the P block elements. General trends in the properties of P block elements. There are certain properties we are going to discuss about the P block elements, and those properties are electronic configuration, oxidation state, metallic nature, ionization enthalpy, electronegativity, anomalous property of first element in each group, inert pair effect, and finally allotropism. So these are the properties we are going to discuss about the P block elements. In this video we will discuss about only electronic configuration. Then in the coming video we will discuss all the properties. Okay, so let us move on to let us study the electronic configuration about the P block elements. Okay, Vama. Okay, dear students, the general electronic configuration of P block elements is NS2 NP126. 126 means certain elements will have one electron in the p orbital, whereas some other element will have two electron in the p orbital. So a particular element will have NS2 NP1, then the other will have NS2 NP2, then the other will have NS2 NP3, and so on up to P6 they can have the electronic configuration. So the general electronic configuration is NS2 NP126, which means in the s orbital permanently two electrons will be there. Whatever element it is from the P block, it will have two electrons in the s orbital. Only there is a variation in the number of electrons in the p orbital. Okay, va? Okay, so what is their general electronic configuration? Their general electronic configuration is NS2 NP126. Okay, Vama. Okay, and there is a trend we know, if the elements are present in the same group. Okay, if you take boron family, boron, aluminium, gallium, indium, if we take that family, they will have similar outer electronic configuration. Their outer electronic configuration will be the same, but only one change will be there. That change is their principal quantum number, which means the value of n. If the element is present in the second period, n value will be equal to 2. If it is present in the third period, n value will be equal to 3. If it is in the fourth period, then the n value will be 4, and so on. Okay, so what is the important point given here? The elements of same group will have similar outer electronic configuration. Their electronic configuration will be the same, but what will be the difference? Only there is a difference in their principal quantum number. In order to demonstrate this fact, I have taken the elements from boron family, carbon family, and nitrogen family. Okay, Vama. Okay, so these are the elements of boron family. What are they? Boron, aluminium, gallium, indium, thallium. Okay, boron is present in the second group. Second period. Aluminium is in third period. Gallium is in fourth period. Indium is in fifth period, whereas thallium is in sixth period. Now look at their electronic configuration. Boron's electronic configuration is 2s2 2p1. Aluminium's electronic configuration is 3s2 3p1. So the number of electrons present in the s orbital and in the p orbital is the same for all the elements, but what is the difference? The n value is different. Here 2, 3, 4, 5, 6. So that is given here. The elements of same group will possess similar outer electronic configuration. Only there is a change in the value of n, which means there is a change in the principal quantum number value. Then next, carbon family also I have taken. The elements of carbon family are carbon, silicon, germanium, tin, and lead. Here the electronic configuration of carbon is 2s2 2p2. If you look at the successive electronic configurations, they are also the same. So here the general electronic configuration is ns2 np2, but n value varies accordingly. Can you able to understand, students? Look at the electronic configuration: 2s2 2p2, 3s2 3p2, 4s2 4p2, 5s2 5p2, 6s2 6p2. So these are the elements of the same group possess similar outer electronic configuration. Only there is a change in the value of n. What is n? N is the principal quantum number. The nitrogen family is also given. The elements of nitrogen family are nitrogen, phosphorus, arsenic, antimony, and bismuth. Here what is the electronic configuration of nitrogen? Outer electronic configuration is 2s2 2p3. Then successively we can write. For phosphorus it will be 3s2 3p3. Then for arsenic it is 4s2 4p3. For antimony it is 6s2 6p3. And for bismuth it is, for antimony it is 5s2 5p3, and for bismuth it is 6s2 6p3. Is it clear, students? Do you have any doubt? I think you may not have any doubt. Likewise, if we take next family, what is the next family? We have boron, carbon, nitrogen, then oxygen family. If we look at the elements of oxygen family, they will have the electronic configuration of ns2 np4. If we take halogens, then their electronic configuration will be ns2 np5. Whereas if we take finally the noble gases, they will have a completely filled electronic configuration ns2 np6. Is it clear, students? Okay, so with this video completes. Go through the video and have a clear understanding. Thank you.